So, we're going to start with a questions-based approach. I'm going to give a real-life example here. So, we're going to go through x plus 3 equals 5. Now, I'm going to assume the identity of two tutors, okay? So, this here, I am tutor number 1. I'm going to take my glasses off, okay? So, you know this is, I'm tutor number 1, right? Okay, tutor number 1. Let's see, I need... Okay, Connor, you're going to be my student, okay? Okay, so Connor's my student. Okay, and Connor, in your math question, or your math homework packet, you have x plus 3 equals 5. Okay, so tutor number 1, this is what I'm going to do. Okay. So what you do in this instance, Connor, is you're going to subtract 3 from both sides of the equation. And then we have x equals 2 because 5 minus 3 equals 2. Okay, got it? Do you understand now?
Got it.
Okay, Connor understands. Okay. So that's tutor number 1. Now I want you to compare this to tutor number 2. I'm putting the glasses on, so I'm assuming tutor number 2. Okay. So tutor number 2 is this. Okay, Connor, what are you trying to do here? What is your question?
I want to figure out what x equals.
Okay. So what are you going to do? How are you going to figure out what x equals?
I am going to make it so x is only on one side of the equation.
Okay. So you're a little too advanced as a student. I'm going to role play actually a student. That might be a little more accurate to the experience that we as tutors go through. Okay. So a student might say, well, I know that x equals 3. Okay, so x equals 3. Okay, so then tutor number 2 is going to say, okay, well, why is x equal 3? Well, because 3 plus 3 equals 5, and I know intuitively, I just know that x equals 3. Okay. So tutor number 2 then would ask, okay, so if it's true that x equals 3, then it must also be true that 5 minus 3 also equals 3, because if you take two parts, if you take 3 and 3 and you add them to a whole, that whole, take away one of the parts, has to be that other part, right? So it must be true that 5 minus 3 also equals 3. What is 5 minus 3? What is 5 minus 3, everyone? 5 minus 3 is 2. Ah, okay. And the student's going to say, shoot, it's 2. Well, why shoot? Why is this a problem? Well, because 2 doesn't equal 3. My original hypothesis was that x equals 3. Okay, interesting. This is still tutor number 2. So what does that mean, student? Well, it means that my original hypothesis was wrong. Tutor. Okay, so what's the next approach? Okay, now I'm going to stop the simulation. What did we notice? What were the differences in those two tutors? What were the different? What did you notice that was different in my approaches there? Yes, Taylor.
In the second tutor, the student actually had to think the answer
Okay.
and retain information.
Good. Okay, what else? So the student had to think and retain and be analytical about their approach. What else? What else? Yes.
In the first one, the tutor just told the student the answer. On the second one, the student had to figure out their own way to the answer.
Exactly. And insofar as the student figured out their own way, they also built a framework for tackling similar questions and a framework for checking their work once they had finished. So it wasn't enough to just come up with an answer. The tutor prompted them to say, okay, so if that is true, how can we check that? How can we use the fact that x equals 3 and plug it back in and manipulate it? And as that's happening, the student is learning, okay, so these are the inconsistencies in my own logic, and this is how I can correct them. Okay, so that's the question-based approach. Now we're going to go over simple examples, and so this is that part that I was talking about with David. And so with David, I had to take a complex question and I had to simplify it. So let's say, for instance, that this is the question that we started with. Okay, so 3x cubed plus 2y squared plus 4x cubed minus 5y to the fourth plus 3y squared. Okay, now the question says, okay, simplify, condense this equation. Okay, so the student is thinking, oh shoot, I have no idea what to do. In class, my teacher went over it and it made a lot of sense, but now that I'm sitting here and I'm confronted with this, I have no idea what's going on. Okay, tutor number 1, here he comes. Well, what you're going to do is so you see how these there are 2 x cubes, so we're going to combine those two terms, and then there are 2x squared, so we're going to combine those, so it's going to be 7x cubed plus 5y squared minus 5y to the fourth, and that's your answer. Got it? Okay, tutor number 2, here he comes. okay? This is how tutor number 2 will approach it. Tutor number 2 will notice, okay, well actually, even before they notice, let's ask some questions. Okay, so this is tutor number 2 asking the student. Okay, so what's confusing to you? Well, the student says, well, it's just so big and I have no idea. Okay. Tutor number 2, being a good tutor, would recognize that it doesn't matter how complex a question is, because that's the whole point of math, and teachers give us hard problems so that we can confront the actual, like make sure that we understand the concept. So tutor number 2 will understand that combining like terms is the issue here, not the fact that the student that couldn't possibly comprehend a complicated question, so the tutor just has to tell them exactly how it goes. This is what tutor number 2 might do. Okay, so if we're talking about combining terms, let's break this down into its easiest possible component. What does a plus a equal in algebra, right? A plus a equals 2a. Okay. What about a plus b plus a? Well, that equals 2a plus b. What am I doing here? As a tutor, I'm starting to identify a couple of things. One, that we can combine like terms. That a plus a does in fact equal 2a. But I throw a twist here. And I say that a plus b, I'm trying to get my student to say something like 3a to combine all the terms, which is wrong. Or maybe they would say 3b because they see 3 terms here. But I'm doing it in a super simple and easy to understand format. So the student knows and can see that, well, actually, this is going to be 2a plus b. We're taking, and then the tutor can summarize. So what, well, they're going to have to summarize. They can ask, what did the student understand? Well, the student might say, well, I know that I can take my 2a's and I can combine them, but my b isn't going to combine with any of my a's. And so I know that these are going to be separate things. Okay, good. So we have this second level down. Perfect. So we know that like terms can combine, and we know that terms that are not alike cannot combine. Do you see how I'm building blocks? Now, we're going to take it a step further. Now my like terms, I'm going to throw a twist on them. Not that this is any, again, this is all combining like terms, but I'm building back up, right? So now we have our like terms, but they have exponents. So we have an a squared, we have a b cubed, and we have a b squared, right? What I will eventually get, what tutor number 2 is eventually going to get their student to do is combine the a's and recognize that the exponents now are important. We cannot combine the b squared and the b cubed because exponents don't combine. And so this is the result of our question. 2a squared plus b squared plus b cubed. And now, our original question, which is 3x squared plus 2y squared plus 4, yada, 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 yada. At this point, what does the student now understand? A couple of things. One, that we can combine like terms. So we have to look for terms that are similar. 2, when terms are not the same, both in different variables and in different exponents of the variables, when they're not the same, we cannot combine them. So what do we have? So now we can combine our x cubes. We can combine our y squareds, and our y to the 4th isn't going to combine. So we started here, but the tutor was able to systematically break down and build back up to the difficult question, right? So what was the difference between tutor number 1 and tutor number 2's approach? Hands again. What were the differences? Tell me. Yes?
Tutor 2 recognized that they could take a complex problem and break it into its simple parts to explain how you would get back to the hard problem.
Exactly. And the student was the one that eventually did the hard problem themselves. In this hypothetical, let's say that our student was really following along, and they should have, because we're great tutors, because we're true tutoring, right? And the student would have eventually followed, and they will solve that question that they started with in the first place. They're going to be the ones to solve this. But they have to do the work to lead up. Thank you so much for coming. I'll see you all later. But they were the ones that had to build back up, and they were the ones that ultimately solved their own problem that they started with. Aiden, let me ask you a question. In all of the times that we worked together, when you had a difficult question, something like this, okay? Did I ever tell you one time, okay, so you're just going to combine the like terms, you're going to combine x and y, and this is what you get. Did I ever do that to you? No, right? I probably made you want to do this the amount of times that I said, Well, no, we're gonna break this down, and we're gonna drill this, and we're gonna do each of these steps, we're gonna do a variation of this 5 times, we're gonna do a variation of this 6 times, so that Aiden can be the one to get the solution to this question. Aiden, what grade did you finish with in math this semester? What percent though?
97%.
Yeah, so Aiden finished with a 97% in his class, which is fantastic. That was all of Aiden's hard work. But I also am confident that had I not broken these systems down like this and made Aiden be the one to ultimately solve his own questions, I don't know if maybe we would have gone to 91 or 92, but at 97%, I don't think I ever got a 97% in any single one of my classes, okay? So it's a huge accomplishment. It's a huge accomplishment and it means something. It means that something is working here. Okay.